Good evening. Hope you all are fine. In previous class, we did the basics of kinematics and then distance, displacement, and then we did speed and velocity, some basics. Now we'll do different types of speed. So let us see. So speed is classified into three basically. One is called uniform speed. Uniform speed means equal distance in equal interval of time, right? I repeat, equal distances in equal intervals of time. Variable means unequal distances in equal intervals of time. And when we talk about average speed, it means simply total distance divided by total time taken. Now let's say we want to show this uniform speed with the help of curve graph. What we can do is we can have position time graph, which is, let's say, x in meter, which is our distance. Okay. And time in second. And if you plot this graph like this shows that the equal intervals of time, equal distances are covered. So this is said to be uniform speed. Then variable unequal. So graph remains same, which is position time graph. X represent position in meter and t time in second. And let's say graph is like this. So this is variable. When it comes to average, this is total distance upon total time, which we can write S upon T. Simple. Now, let's say an object covers distances with different velocities and different distances are covered. So S1, S2, let's say S3. Time interval is also different, T1, T2, T3, and so on. So we can write it S1 plus S2 plus S3 And time can be distance upon speed plus second distance upon different type of speed plus third type of distance divided by different type of speed. Now, this is in general. Now some, let's say, special case. Special case is when half distance is covered with v1 velocity and next half with v2. Then v average. In this case, s1 plus s2 divided by s1 upon v1 plus s2 upon v2. Since s1 is s2 exactly half, so it is s, which means v average can be s1 and s2 becomes 2s divided by s1 means s is common, 1 upon v1 plus 1 upon v2. Now if we solve, what we get? S gone, and this v average becomes, this v1 into v2 will go up, so twice v1 v2, and in denominator we are left with v1 plus v2. Means, this, having said that, this is special case when, if this is the distance starting origin to the final destination, but half of the distance and next half must be covered with v1 and next half v2, exactly half, then this formula is applicable, that v average is 2 v1 v2 divided by v1 plus v2. If it is common, not defined, undefined kind, then we write s1 plus s2 plus s3 by t1 plus t2 plus t3. If it is in general, then total distance by total time, s upon t. Right? So this was regarding speed. Similarly, let us look into velocity. So let me clear this first. Now let us see different types of velocity. Okay. So when we take different type of velocity, here also we have first, which is a uniform velocity. Then second, variable or non-uniform. Then third is called average velocity. First, let me clear one thing. When we talk about speed and velocity, main difference is distance and displacement. In case of speed, we take distance. In case of velocity, we take displacement, right? So in case of uniform velocity, we can have this curve like, and in this curve, let's say this is x position in meter, but This position is distance, displacement. Time remains same. Second, uniform, we can have a straight line curve. So in each time interval, this will be uniform. Means when equal displacements are covered in equal intervals of time, then it is said to be uniform velocity. So only displacement is coming. Over here, how it will be different? Variable one, it will be different like this. So x meter in position, time in second. So when unequal distances are covered in equal interval, displacements are covered in equal intervals of time. And average again, total in place of distance, displacement upon total time, right? Now we can see, if you want to formulate the average velocity, can be change in displacement, which is x2 minus x1 divided by t2 minus t1. This is called change in position divided by change in time. That could be V average as, let's say, delta x upon delta t, right? Now we may do the instantaneous velocity. Instantaneous velocity. So when we talk about instantaneous, means velocity at a particular instant. Velocity at a particular instant. The same V instantaneous, INS, can be del x upon del t, but here we write limit del t tends to 0, means this denominator del t is negligibly small but not a 0, or it can be like dx upon dt. Okay, so hope you are getting it, and these are the basics of the speed, velocity and all. Now we can add in this, which is called acceleration, right? And when we talk about acceleration, better we try in the next video. Thank you so much. May God bless you. Do write your comment to improve. Do like and share with your friends. Thank you so much.